Hi, I'm Semih Alar. I'll demonstrate how I record, edit, and implement sounds into Unity by using Wwise middleware. I'll show you the process from capturing sounds to editing and finally integrating them into the Unity. To create ambient elements, I went outside and recorded sound of wind, rustling leaves, wind chimes, insects, and birds. After editing them and selecting the ones that best fit the game, I added them to the Wwise project. I filed the remaining recordings in my sound library for potential use in future projects. I added the main ambience element wind sounds into the random container in Wwise project using the loop feature. For the remaining sounds, I added them to a seconds container in Wwise and used delay properties to adjust each sound to play at different intervals. Consequently, all sounds except the wind will play at unpredictable intervals, enhancing the player's realistic ambience experience. Within my Wwise project, I created a state consisting of 3 different scenarios: indoors, outdoors, and temple. I used the same ambient sound for these 3 environments but altered them based on where the player entered, avoiding overloading the project. As a result, when the player moves from outdoors to indoors or into the temple, most of the ambient sound will change, fluctuate, or become inaudible, mimicking real-life experience of muffled outdoor noises in enclosed spaces. Subsequently, using the state I created, I fine-tuned transitions between these 3 environments within the program for smoother shifts. Then I linked the ambience event to the camera game object in Unity. I needed to control the ambient sound based on the state I created. To determine whether the player was indoors or outdoors, I utilized the exposure manager script that came with the project. I used the light change parameter here to facilitate the state change for the ambience. However, due to some multi-tiered indoor design and changing lights as the player ascends levels, sometimes the game will misinterpret the player's location. To counter this, I generated a zone counter to double check if the player was indoors. To determine if the player was inside the temple, I added a collider inside it. Upon entry with the player tag, it switches to temple state. When exiting, it changes to outside. There are several bonfires across the map. Afterward, I flawlessly looped these sounds and placed them in the Wwise project. I adjusted changes in the attenuation when the player approached or moved away from the bonfires. I ventured out for field recordings to capture the unique sounds of footsteps in puddle. For the remaining footstep sound, I relied on my sound library to find the perfect fits. Within my Wwise project, I created a separate switch container for each surface and added 4 random containers to each. This setup was necessary because some game surfaces had puddles, and I wanted to control these independently of the player's walked surface sound. To change the sound provided by the play player footstep event based on the surface, I added a ground material switch. I included the ground wetness switch to mix in walking in water sounds based on the puddle's volume for the current surface. To enhance the echo effect of footsteps in the temple, I created a reverb auxiliary bus in the Wwise project, and I included the room state previously made for ambient sounds. Then I routed all footstep sounds through this auxiliary bus, bypassing the reverb effect everywhere except the temple. In this project, as we don't control any characters but can only move the camera, we don't have the opportunity to add footstep sounds directly to a character with animations. Therefore, detecting the camera's position becomes essential. Before this, I wrote a script in C# that will save us from various audio bugs later on. This script checks if the player touched the ground, whether the player is on a terrain tagged as terrain, and finally, whether the player is inside. The reason for checking if the player is indoors is that all the interior spaces in the project have wooden floors. So if the player is inside, we hear footsteps directly on the wooden floor. After checking all these conditions, I developed a script that translates the player positions on the splat map, which checks the textures present. Afterward, I made a script to execute the play player footsteps event and control the ground material switch based on the surface material. Additionally, it determines if the player is walking and, if so, triggers footstep sounds. And finally, if the distance traveled is greater than 1, it plays footstep sounds. Lastly, in the Unity game engine, I tagged all water puddles with water. If the player collides with these tagged puddles, I used a script in C# to control the RTCP link to the ground wetness switch in the footstep script, allowing the mix and audibility of footstep sounds based on the water volume of the surface the player is walking on. Thank you for taking the time to explore my sound design portfolio.